Well guys, welcome back to Spank Ranch Garage. If you're just clicking this video and you haven't watched this one up here in the corner yet, I recommend you do so. It'll be a lot of background of how we got here, why we're making these repairs, and some of the challenges I'm facing. Alright, so if you guys saw my John Deere 410 video with the disaster that happened on a Gland, I now check them to see if they're steel or cast iron or aluminum before I beat the crap out of them. Now once again, I don't have the right tool here, but being that this is a steel cap, it sparks the same way that the tube does. If it was cast, I'd expect to see a much darker spark. We're gonna try to do this a little sketchy, see if we can get it broken loose. Yeah, unfortunately my spanner, the pins are too big to fit this cylinder. So we gotta get fancy with some Allen wrenches here. Sorry about all the background noise. I got the heat on and I'm filtering waste oil, so there's a pump running in the background. All kinds of action going on here in the shop. Oh guys, sorry I missed it on camera there. We got a mess ensuing. Don't like to drop the barrel on its face like that. It's not good. Alright, so there's kind of a lot going on with this cylinder. So this is your head gland, which seems to be in okay shape. Then you've got like a spring that I guess dampens a bottom out event or whatever. And then you actually have cast iron rings on here like a piston. My first thing I'm noticing is there should probably be 2 rings on the bottom here, and there's only one. That doesn't seem like that's going to do anything in that position. And if you guys can see, focus, this O-ring is really pitted and chunked. There's just pieces missing. That's all pieces missing. So that ain't doing no good for us either. And then having these rings flopping around doesn't help either. But what's even more alarming is this piston has seen some S. This is probably the bottom side of the piston, and just gravity has, over time, allowed that to wear. Where did that other cast iron ring go? That's a great question. And I gotta get a light and inspect the barrel. I'm really hoping she isn't scored up. But we'll do the best we can no matter what. It looks really bad on camera with the way the oil is running down the walls and stuff, but in real life, I'm not like wildly stoked on it, but it's pretty good. It'll be enough. I don't see any scratches. You can only reach in so far, but the scratches that I can reach, I can't catch a fingernail in. They're just like visual scratches, and it appears to be that way the whole way. So it is a steel barrel, cast iron rings, and an aluminum piston. So the barrel should survive some nonsense, and it looks like it has. But I did check the parts manual. There's certainly supposed to be 4 rings on here. So I don't think a ring broke and escaped. I can't see it grinding itself up that small and leaving the system. So I think it was put together, missing a ring. This thing obviously has been apart. I'm not the first one in here over the years, so quite likely some tomfoolery has been performed. These threads are very grabby and they're sharp, and they're going to destroy the center seal on this cylinder, but they're also going to snag the rings. I got a lot of cleaning to do in here. There's Loctite or something, or sealant or something in here. But anyway, I need to compress those rings and that center seal to get into the bore part here without snagging on these threads. And you can't just use a normal automotive ring compressor because it would butt up against this face, and then the rings will all expand again and catch in the threads. And you really got one shot to make this happen without damaging anything. So my thought is to carefully measure this and 3D print, or have my brother at Print Practical 3D print a nice sleeve that's going to cover these threads and match the inside bore diameter. and then actually funnel that tool out a little bit so it can become a compression mechanism to slide that piston in like that. Alright guys, there's a 15-minute extend-a-hoe for this extend-a-hoe. So this will allow me to reach all the way down in there, give this thing a quick scuff. If there is any scoring, maybe we can clean it up, though I can't actually feel it because I can't get my hand down there. So we're just going to send it down a couple times on good faith. Just wrapping this in tape just because inevitably it's going to be hard to support this like 5-foot piece of rebar in there, and if it bangs on the cylinder wall, at least the tape will give it a little bit of protection. I just dumped a bunch of brake clean down the bore, and I'm actually able to push it out the other side with this little squeegee I made. I'll do this a couple times. I think that'll just be good enough. Spin-a-doodle. Woo! Boy, did we get lucky there. Also lucky this spring doesn't have too much tension behind it. Uh-oh, don't tell me that's like a threaded piston too or something here. Come on! This cylinder is fighting me to the last minute here. Alright, she might just be hung up on her own O-ring. Unbelievable. This has been the most challenging cylinder I've ever worked on. I just never seen anything like this before. And it's not easy to service. Now I got some more burrs to clean up on this beat up piston, but man. So this O-ring was missing from the kit as well. I had to buy 100 of them to get one. So if you need any, I got you. So I got this piston dialed in about 1/4 of a thou, which is pretty good. I'm going off the undestroyed ringland here. So now we can clean up this edge, which has some peen marks on it from air chiseling it off. which isn't the ideal tool to use, but that's okay, we can recover. Also, the spring groove is pretty torn up, so I'm going to machine that back to round as well. Alright, that should take a spring again. Now another thing I'm thinking is I might want to machine a small chamfer in here just to help that come over that shaft O-ring without tearing it up, because it fits so freaking tight. And there is a little bit of galling inside this piston, so I think I'm going to hone it as well. That must be why it was stuck on the shaft, but I'm certainly not the first guy that's had his dirty little fingers in this thing. So indicating the bore, she's either way out of round or way out of concentricity. You got like 10 thousandths there, 5 thousandths there. So I will dial it back in. That is original manufacturing, because I'm running true to the outside here and the inside is not concentric with it. Nothing moved in the setup. So before we say that, let's check that. Yeah, we're still running dead on the outside here, so great. As good as we're going to get on the inside there. You had about 2 thousandths of variation, but it is a little galled inside, and I know this is not the right tool, but it works. I've indicated a lot of things on center this way. It's just a pain in the butt because everything's super tight clearance. Just grazing the inside here. Probably not even enough to clean it up all the way, but hopefully it'll take off those high spots. Just enough to clean up that bore. It's still got a couple pits and scores towards the center, but nothing that's going to affect sealing on that O-ring. I'd like to face this just because it's ugly, but there's really no performance gain to that. And it's like, dude, there was a nut on this. How is this so beat up? Like, whoever had this apart must have just been wailing on this thing. So this piston's really seen better days. Honestly, it's a pretty simple piston. I could manufacture a new one if we had to, but you know, I don't think we need to. It's gross, but I think it's going to work. I don't see why it wouldn't work. That's nice. All right, so that fixes that assembly fiasco, and I think this little chamfer will give us a much better shot at not screwing up this O-ring. Plenty of compression on that O-ring. Okay. Really got to inspect these O-rings after you roll them over a thread. It's easy to mark one up. Spring fits back in its pocket like it should. Cool, that taper worked awesome. That felt nice. Does anybody see what's wrong here? The whole reason I took this apart was to slide the gland on, and I didn't do that. So back apart it comes. All right. Top cap with our like scraper dust thing in it. So for this top gland, I already pressed one of the seals in. The new one arrived. There's double redundant seals on this. And these are packed seals. So this is like a normal U cup, but it has an X ring like molded into it, pressed into it. So that way this thing is always making tension on the shaft even when it's not being inflated or excited by the hydraulic pressure. They both face the same direction. You don't need to fold these up and jam them in because they just fit straight down the bore like that. And then we have this composite material rod gland thing. And this will get pressed in on top of it to retain all of them. Well, not much of a press fit there, it just goes in. but the cap on the rod holds all this together so it can't just blow out. We get one O-ring here, and then we get a backing ring and an O-ring down here. Oh. Okay. That puppy's on there, feels good. This is on there, we haven't screwed up yet. Surprisingly, we got away with shearing the roll pin on this. No damage to the threads or the end. All right, now we got something we can hold. Hercules is awesome, and there was a pin in the kit, so send this through. And that rod end is locked on there. We'll see how that goes. Drop that into the lift arm. Clamp her down, and now we got something to grip on. Torque spec is 150 to 250. So we're gonna shoot in the middle. We'll see if we can hit 200 before my clamp breaks, flies across the garage. Oh, we got it. We got her. All right, I feel good about that. All right, guys, we're getting closer. So now we're ready to put this together, and the challenge of ring and seal compression without tearing them up on the threads becomes our challenge. There's an inch of threads here, and there's not much chamfer to this bore, so we need to get down in there to compress them. So I drew up this tool. My brother printed it for me. He has a 3D print channel on YouTube called Print Practical. Does a lot of practical printing. So I basically designed this. So this is a tapered cone, and the major diameter here is the minor diameter of the threads in the barrel. So the thought would be that I lube this up, push this over this. This will compress everything really nice. Then we put this into the barrel, slide it together, and then I'll probably have to cut this tool off, unfortunately, because it won't make its way over the rest of the components here. But if it works once, that's all I need from it. It'll serve its purpose. So you can see this tool now has everything on this piston compressed to the diameter of the piston. So those rings are fully compressed, and so is the seal. Now hopefully this will still fit into here, and we'll jam this thing together. Perfect. I felt it, baby. I felt something. Let's go. I think our piston's in there. Dang, that's a tight fit though. Holy crap. I would have never got that without this tool. There's no chance I would have got that. Doctor's got to cut your cast off. Saddens me, but it did its job, so. What would make me really not sad is if I never have to do this again on this cylinder. Little lead hammer action. She's bottomed. Will the gland still thread in? We think so. What a job, boys. Holy crap. Now while we're here, I'm gonna put male to female swivels on this because there were none installed as I found the machine, and it makes it so you have to twist the entire line to get this apart, and that ain't right. So we'll throw some swivel fittings in for ease of serviceability for the next guy, because I hope it won't be me, but you know how things go. It'll be me. Look at what came out of this cylinder. stuff is just destroyed. So I know I didn't do everything right, and I could do a lot better next time, but I don't think we made this worse. Well, it's a nice 18-degree morning out here, and grabbed another batch of hoses yesterday, and it looks like I'm going to be the only guy to install these because I don't see anyone else out here to help me with it. That blows. Same thing as usual for these hoses. They all have to go on and come off in a very specific order. You won't be able to get to them. And they're kind of tricky to route because they go through the boom. So there's a little hokey pokey to go on there. Now ideally, if you had replacement hoses and you didn't pull your old hoses yet, you could put a coupler between them, pull the old hose out, it'll pull the new one in for you. But unfortunately, these hoses were so screwed up and wrong, I had to pull them to measure everything, so I didn't have that opportunity. Also, it's a good idea to cap your lines when you're shoving them through all these dirty areas, because every little piece you get in there is another piece to compromise your hydraulic system. It's not worth it. Frozen to the ground this morning, but this thing actually started amazing. So it's time to bring this girl back over to the garage and start putting this boom back together. All right, so where I left off with you guys last time, that was right before Christmas. Now it's the day after Christmas. We're back on it. I welded a bunch of fat turds on these wear plates here. I tied the top plate into the main boom as well as the shim that was already there. That way that's all tied into one piece. Feel confident that's not going anywhere. Now we need to make the wear plates for the end of this stick, and you see there's this bolt pattern here. I'm hoping to actually reuse this. I will weld the plate on the front like the previous guy did, but I want to at least get a couple bolts in here to secure the back side of it from folding in or anything. Wear plate is made up. You got your 4 factory bolts here. I also added 2 more towards the rear, just because we are making these plates longer than stock. I figured having some support up here so it can't peel away would be good. So now I gotta head in here with the grinder, flat face all these bolts, and we'll move on to the other side. Probably put these in with Loctite when they go in for the final time. The wear plates are in. Swing and a miss on this hole, which I'm pissed about, but whatever, we got one here. Plus the factory 4. Cut the bolts off flush. We look good in there. I'm gonna pull them back out. It's time to stuff this boom back in and hope everything fits and wiggle these plates up in here very carefully like. Alright, so we're fighting something that I knew was possible and hoped wouldn't happen. And that is, there's been repairs to the boom made here, and this repair is low. So it's pinching the extend-a-hoe. So we have space here, you got space here, but you don't have any right here. And I pulled on this pretty hard. I don't want to jam it like super permanently. And I don't think this extend-a-hoe even has enough power to overcome this to wear itself in. So I'm thinking I got to get this piece hot and try to pull this weld up and make some room here, because the rest of this seems pretty happy. Got a piece of flat stock laying on here. I mean, for the work we're doing, the boom is straight. And honestly, the end on the backhoe isn't too bad either, despite all these gross welds. So was it really one little localized low spot or something more bent here? I'm wondering if I need to pull the whole stick out and lay this down the inside of this. Maybe that's bananaed out or something. The bottom of this thing is straight as can be, and the boom is straight, but the stick is straight top and bottom. So it's got to be these screwed up flanges here. I'm measuring a solid 7.5 on this thing across the entire length of it, and I don't have anywhere here less than 7.5. But maybe things just bind up because something's slightly twisted, maybe. Well, we can visually see it is slightly twisted, but how are we going to make it happen? Now before we go too far, I gotta go watch the old video to determine where the hose is on the top or the bottom of the cylinder here. For whatever reason, the way the ports are in the barrel and the way the piston just lays with gravity, it's important that it's in the right orientation. So at least that's what the manual says. Let me go check that. It'll be routed through the boom, which isn't gonna be fun, but that's a project for another time. We gotta get the rest of this thing in some type of shape before we do that. Guys, I am glad to have my stick back. Several problems with the shimming. I took it out, I ground a radius on all the sides of them, and that helped substantially. I got about, I don't know, I was all there but like 9 inches, and it was still binding up at the top. And I literally had to custom taper the last 18 inches of the shim with a grinder with a 7-inch disc on it, and I was just in here just grinding until it's just perfect. It is really good right now. It has, well, when the boom fully up, it has no play. I mean, it literally comes up and stops pretty much because it gets tight, which isn't ideal, but this stuff's gonna wear in, especially digging and just banging this thing around. You get some dirt in there, this whole thing's gonna lap its way together and start wearing out again. So she's as tight as she can be right now. The extend-a-hoe boom is strong. It'll pick up the whole back of the backhoe, just plunging the stick into the ground, which is pretty cool. You know, the cylinder rebuild went great. So anyway, now we're down to capping the end of the boom here. If you remember in the first episode, I had to cut this off. We still got to slide our wear plates in and then find a way to close this up and weld this all back together. Looking back after today, I should have never touched this. I should have pulled the cylinder out and rebuilt it and moved on with my life, because I just got way too many hours into making a 50-year-old extend-a-hoe not sloppy. And it's okay for it to be sloppy. Like, you know, I'm kind of a nerd about having tight pins on my machines and stuff, but it's not realistic. It can be done, and you'll see this. This is gonna be great, but it's like, I'm spending all this time just so the bucket doesn't rock back and forth a little bit, and it's like, why? I think there's something wrong with my head, and I need to get over it. I think the challenge interests me, but then when I actually start doing the work and I realize how much of a pain in the butt it is, and I start to change my tune a little bit. You know, when this thing was stuck in there and I was sledgehammering it for 40 minutes to get it out, I was saying, man, wouldn't it be nice to have a sloppy extend-a-hoe? But whatever, we made it, we got it, we learned stuff. Well, I learned stuff. I hope you guys learned what not to do, and then All right, this side is welded together. Still practicing stick welding. That came out actually really nice for my standards. But now the challenge is we have a large gap here that needs to close. And that's because the whole top of this thing spread apart when I cut that. She's under a lot of tension, so we got to think of a creative way to pull this gap closed to get welding on it. I got to put my thinking cap on. This feels like the most ghetto thing I've ever done in my life, but if we're gonna have a chance of getting this is gonna be it. Yeah, I mean, everything's welded on fairly welded. I didn't want to go crazy with it because I got to cut it all off again. So what I'm really learning here is I don't want to take a older extend-a-hoe apart ever again. I'm good on this. This has been a great experience, but I don't need to do this again. Okay. We're heading in the right direction. Let's get some lids on because this is going to blow. The wear plates up front here look parallel, so I could probably tack this now. So that's touching, that's ready to tack. Let's make sure this thing still works. That looks great, that's good all the way to there. The back here's got a pretty big gap still, but I think that's just how I cut it. All right, time to weld it. I can't complain about that fitment. That is phenomenal. Probably better than any of these old machines at this point. So let me get a bead laid in here. So now we can cut our bracket off and go to town. The relief of this is huge to me because I was very worried about this, and it did turn out to be a pain in the butt, but we got through it. All right, one finger injury later, and we got this stupid collar back on the extend-a-hoe. So gonna wrap it up. It's laid out. Everyone's probably mad that I'm running the welder, grinding, hammering, what have you. We'll get back to it in the morning and hopefully finish this damn thing up. It has been taking way too long. Did you see that? All right, that should hold us, hopefully. Great. That's gonna come up. I'm just working through so many injuries right now. Screwed up my lower back, my hands split open, both of my hands are sore from grinding. It's raining out, it's 39 degrees. It's not gonna be a fun day, but we'll get her done. So it's nice to see this cylinder in position here. Now we can start working down towards the bucket end again. Boy, had to make custom washers for either side of this, so the snap rings couldn't pull the bushing through. That's how I found it, but it's fixed now. All the other snap rings and pins are in, and now we get cursed by the extend-a-hoe for the 50th time. If you guys remember in last episode, I found this cast H-link at the junkyard, and it was in good shape. So I grabbed it because it didn't need bushings, where my fabricated one here, the bushings are blown out and this needs to be line bored. Well, I go to install it. The boom widths are different between the extend-a-hoe and the fixed boom, where at the tilt cylinder or the curl cylinder, it's exactly the same. So here's a demonstration here. This is a boom tip from a 410 regular hoe, and that's a boom tip from a 410 extend-a-hoe. You can see the bucket boss down here is the same width, same size pin, but this is much narrower. And that's because you need the width of this to get around the actual boom when it's all the way retracted and you're trying to empty your bucket. Now I understand why it's built this way. These plates are wide so they can clear the collar. So this isn't even all the way bucket dumped, but basically this linkage needs to be able to clear the actual boom here, where on the non-extend-a-hoe, this stick is so tiny, it just doesn't matter. So I guess we're sticking with the fabricated piece and we need to fix the whole thing. So great, there goes my afternoon. Something to note, if you buy a Chinese boring bar and they tell you it's 5/8, it's actually probably 16 millimeter, and you will have to turn it to make it fit an American 5/8 tool holder. But you still can't beat it for 25 bucks with 10 inserts. All right, so this is the crazy looking setup. So basically I don't want to spread or unspread these ears at all. I want them to be in their natural state, and their natural state is not really that parallel, and they're not really that straight. So pretty well clamp the bottom down, let the top hang as it wants, slide a machinist jack in there, bring it up just till it touches, and then clamp the whole thing down. Let's bore it out for the first bushing. The first bushing's not so important, the second bushing will be important. Listen to how buttery that's cutting. This is my first time using a boring bar with an indexed, takes indexable carbides. Usually I'm just running a boring bar like this with a brazed on carbide, much smaller shank. I finally got a number 2 boring head for the Bridgeport. It takes a 5/8 shank, so you can put a decent boring bar in there. Man, it is so much happier going through this stuff. I can take bigger cuts, way less chatter, way happier. Can't beat that. The geometry of that tool is just so spot on, you can hardly even hear it cutting. But it's cutting. It's a 15 thousandths cut. So nice. It's not an ideal press fit. I was hoping for a little more of a press fit there, but this bushing is slightly out of round after the hardening. After we oil quench this, it's not totally round anymore, so my measurement probably wasn't spot on with it. It's still gonna work well because this piece is warm from boring it. So that'll stay. Now we're into the tricky part, the part I've been dreading, the part I'm worried about. Not sure if you guys can see that gap back there, but that's pretty much how much it's egged. However, there is a slight misalignment because, you know, it's not going into that bushing. See how we're very close there? We're very, very, very close. There is misalignment. Now that's okay, because we're putting in a bushing that's so much bigger, we can move this hole to anything we want. And with how slopped out the rest of everything is, we're not wildly worried about parallel between these two axes. If everything's within like 10 thousandths of an inch, this thing is gonna work perfectly. This is not a precise operation. It's more precise than just going at it with a die grinder or heating and beating things and whatever else, but this is not like precision machining situation here. This part's still gonna work. We're flipped over here, pin in the bottom bushing, top bushing on the pin, and half of me is saying, man, what if I just scribed this bushing onto the part here and then centered my boring head on that, punch it through? That would probably work for what we're doing here. So I got lucky doing it the ghetto way here. You can kind of see and feel there's no more than just a smidge of play in here. So after pressing the one bushing in, it shrunk a little on the ID because I had to hammer it in so hard because I came a little short on that one. So I cleaned her up with the old Winging It 1000 here, internal flap disc. And this slides and glides nice. Now this is a piece of 150 round stop. This is actual chromoly pin material that I'm going to be using, and that fits as well. No actual play, like anything you could measure on a piece of equipment like this, so I'm happy with it. That was not the right way to do that, super half-ass, but I got it done in like an hour, and I was thinking this was going to take me way longer to do it the right way. So I didn't know that I was going to be doing this until today when I started. My plan originally was to actually build a line boring setup with a mag drill or potentially run it on the lathe, but I was going to build a bearing setup with some cones and a shaft to actually line bore stuff properly, which I would still like to do. A couple viewers asked what would I have done if I had to do this. This is not what I wanted to do, but I'm stuck in a position where I just gotta get this piece of crap done and get it out of the garage. So I didn't get to do what I was fantasizing about of building the actual setup. So we'll have to wait and we'll build an actual line boring setup in the future for something else. On a better note though, look at the shine inside those bushings after hardening and then hitting them with that flap disc. Pretty cool. Okay, that should work. So now it's bucket link bonanza over here. I have two pairs and they're in varying condition, but that is pretty ovaled. Though the big hole doesn't look too bad, and the more yellow ones, the small hole looks decent, but the big hole is not great. I was going to weld these up and put them on the mill and make them round again, but I don't think it's worth it. I think we already accomplished more than what we needed to accomplish, which was the sloppy extend-a-hoe. This sloppy link is pretty nice now. And then the huge amount of slop up there. plus making these new pins is going to be more than enough for a machine of this age and condition. So I'm going to leave these links alone. I'm not going to get carried away and bore 8 more holes, but I am going to go make new pins from some 4140 here, 1 3/4 and 1.5 inches. They should wear pretty nice. Alright, there's one finished pin. 4340 steel, pre-hardened. Should be pretty equivalent to a stock pin at a fraction of the price, so nice. Now that's kind of in a tough spot, because when you're really digging, that ends up hitting the dirt. Here's the old grease fitting. Totally worn flush, so that might be a yearly replacement, I don't know. I gotta say I'm kind of impressed with that move right there. Now we're going to put this in the digging position, which means we're going to grab the lowest part of the link here. The lowest part of the bucket. It was up here. You'll get a lot more breakout force this way. I don't know why these aren't greasable. Do you think I should put a Zerk fitting in them and make them greasable? Is it because they're always in the dirt? Maybe they think it would cause premature wear? I don't know. Curious what you guys think about that. All right, guys, we did it. This is very rewarding to see this piece of crap back together. I probably have 20 hours into this project. It took forever. I mean, it really escalated out of control. The extend-a-hoe, absolute pain in the butt to work on. But I'm glad we did. It's nice and tight now. Cylinder holds, doesn't leak down like the old one did, doesn't leak fluid. Bucket's fixed up. Thank you, Jesse, for welding that up for me. I did a little welding on the front of it to give it some more life. Still got crap to grind off of it from accessories someone else welded on there. I got to get a couple more washers for my pins. I am short a washer over here, and I'd like to do a little better on the spacing on a couple of these, take out additional slop. I'm also curious what you guys think of these big safety pins, Jesus clips, whatever the heck they're called. I bought a bunch of big ones like this to use for the bucket to make it a little easier to change buckets. I'd use cotter pins on all the pins that stay in, but they kind of hang out a lot and I think they might get knocked off. Let me know if you've used them with success or without success. Now after all that, how does she look slop-wise? That's it. Still some movement at the bushing that's in the actual stick, the we're not going there. I mean, this bucket moves probably 1.5 to 2 inches at the tip. Well guys, I'm gonna finally wrap this video up. If you're still with me here, I appreciate the hell out of that. This job pushed me very hard. Everything's really heavy here. It's wearing me out physically. That hydraulic cylinder that we rebuilt was something I'd never seen before. We faced all kinds of challenges with that. And then shimming the slide on the extend-a-hoe was a disaster. And then all the machining, all the pin making. It just took a lot of time. It's Christmas season. Spent like 4 or 5 days cleaning up the house, getting ready to have this big Christmas Eve party. There's so much going on. It's just a lot of stuff happening at once right now. So I'm glad to finally put this project to bed. I got to order up a couple more washers to finish these pins up, and we'll be done with this. One thing you'll notice is I'm not taking a lot of pride in the appearance of this machine like I did with the dozer. I put similar amounts of work into my dozer, and I painted it, new graphics. You know, I made the thing look perfect because I was very proud of that machine, and I still am. Backhoes aren't that cool. You know, they don't really do anything great, but this is a useful tool that I really, really need. I honestly can't live without it. I'm on hold right now at my other property because I don't have this piece of equipment down there and ready yet. So we're definitely gonna get a lot of use out of this thing. It's set up to be my right-hand man. Hopefully we'll be there reliably soon. Anyway, stay tuned. I got another video coming out about this where we're gonna work on a really cool old school accessory that's gonna make this backhoe way more useful around a homestead / woods environment. Thanks for watching Spank Ranch Garage. Let me know what you think about this down in the comments, and I'll see you next time.